but obviously you can change these to match the ones that are in your assignment. But essentially, you know, we've got an E over D value that goes into that equation, right? So if you recall, there's two things that we need to input into that equation to calculate friction factors for turbulent flows, right? Reynolds number, right? You need that for laminar, right? 64, the Reynolds number gives you that friction factor, but then also that relative roughness, right? That's that E over D, and that's that was that right-hand vertical axis on the Moody diagram. So I'm just going to throw in a number here, 0.01.
Right? It was 10 to the negative fourth.
Okay, so I need another couple zeros in there, right? Right? Okay. And then Reynolds number, right? And so I'll start with equals 10 to the fourth, right? And what I'm going to do is, you know, we'll run this over a range of Reynolds numbers. So I'll just do this, you know, times 2 or something like that. So it'll grow for us, and I'll just fill this down for a few values, whatever, right? And so then what we need is this equation for, you know, our Colebrook equation, right? And if you recall, this had, you know, 1 over the square root of f, right, on the left-hand side of the equation, right? And I'm just going to put in a number here, 8. You know, I mean, just throwing in a number, right? Whatever it is. And now I'm going to put in the Colebrook equation. Okay. And if you know, look back here, notes it's -2 times log base 10, right? And then it had the E over D value, right? And I'm going to go ahead and freeze that so that when I fill this down, it won't, you know, it'll stay frozen, right? And then it was divided by 3.7, and then plus 2.51 divided by the Reynolds number, which I have in this column right here. And I'm not going to freeze that because I want that to fill down the sheet, right? And then it was times 1 over the square root of f, right? Which is this one right here, right? And then all of that was in the log, so I'll close up those parentheses, right? So, okay. And so now what we're seeing is, of course, that, you know, if, you know, we just threw in a guess here of 8, right? And if the right-hand side, you know, came out to 8, then actually 8 is the right answer, right? For 1 over the square root of f. Does that make sense to everybody? Right? Because that was the whole problem with the equation, that we had 1 over the square root of f on both sides of the equation, if you recall, right? And so I just guessed a value of 8, and the equation says, well, no, it's actually 5.38. Yeah. And so, you know, we could guess another value, right? But maybe I should listen to the math, right? And I tried 8, and the equation said, no, it's 5.38. Maybe I should listen to the equation and say, well, all right, let's try 5.38, right? Or 5.382 or 383, whatever, right? And now it says, well, no, I think it's actually closer to 5.72. All right, let's try 5.72. And now it's saying, well, no, it's maybe 5.67. Do you guys see what's happening here? Within a couple of tries, I mean, I've got this down to, you know, 3 decimal places, right? And you can only read the Moody diagram, if you recall, you know, you can only read the Moody diagram to probably about, you know, in terms of friction, you can only get it to maybe, you know, that 3rd decimal place anyway, right? Okay, so essentially, and of course, this is 1 over the square root of f, so f is just equal to this, 1 over that value squared, right? And so this would be, the f value would be 0.031. Right. Now, essentially, I don't want to necessarily have to do this by hand. I want this cell here to equal that cell there, right? I want these two to equal each other. So I want this cell to equal that cell, right? What's going to happen if I do this, right? It's going to be like, oh, circular reference, right? I think we've all hit that problem before at some point in our lives. But there is a method to the madness here. What you can do is go under File, and your Excel version might be a little bit different than mine, but it's pretty much the same. Options, I think I'm in the right spot. And then you go under Formulas, and then Enable Iterative Calculations. So it's this guy right here, right? And 100, that's the default, that's fine. I mean, maybe we want to geek out, and throw in a couple extra zeros in there, right? That's totally not necessary, but whatever. Keep the silicon hot, make it work a little bit harder. And now we hit OK, and look at that, right? And it's got this, down to however many digits. And now we can just fill this down, right? And now we have for different Reynolds numbers, right, what that friction factor is, right?
I'm just wondering, how did you fill it down? Like I saw that you didn't drag it.
Yeah, I had it, of course, when you've got a column that's already filled adjacent to it, like, the Reynolds number was, then if you notice how my mouse, when I go in the bottom right corner right there, the little square, see how it changes to a thin plus sign?
Yeah.
And if you just double click that, it'll autofill down.
Oh, okay, cool.
See, I can still teach you guys something, right? And so now, and of course, now we can change the U over D, this could be 0.05, and it auto updates everything, right? Okay, so you can make a little spreadsheet like that if you like, and just have handy for when you're doing or your calculations and things for some of the other problems coming up. Okay?
What's under your E column?
The E column was I just took it and inverted it because the equation is written in terms of 1 over the square root of F. So now all I did was invert it and square it so that I get F.
Okay, thank you.
Right, the actual friction factor, right? Yeah, so that's what I try to label that up there. F. It's gonna,
And what is your Reynolds number column?
The Reynolds number is just Reynolds number. I just started with 10 to the 4 and then just increased it by a factor of 2 when I filled it down. Did that answer your question, Kirsten?
Yes, thank you.
Yeah. So, because remember, those are the 2 things we need: is Reynolds number and E over D. Right. We could have done the same thing, kept Reynolds number fixed and let E over D vary, right? But okay. Hopefully.